So looking at our next piecewise function in number 4, we have f of x equals x plus 1 if x is less than 2, f of x equals 2 if x equals 2, and f of x equals x minus 1 if x is greater than 2. So we've got f of 1 in part A, 1 is less than 2, that's a true statement, so we're going to use the x plus 1 piece of the function. So f of 1 equals 1 plus 1, which equals 2. F of 2 equals 2, right? That's the part of the domain that's in. So for this part of the function, we're just going to use 2. So lots of 2's here. F of 2 equals 2. And then for f of 5, 5 is greater than 2. So we're going to use the x minus 1 part. F of 5 equals 5 minus 1, which is 4. Okay, so if I wanted to graph this function, let me go ahead and draw the xy axis here. Do a quick little sketch. All right, so first of all, let me go ahead and graph this 2, 2 ordered pair in part B. So 2, 2 would just be that point. That's all that this piece of the function says. It basically says that the point 2, 2 is a member of the function. So if x equals 2, f of x equals 2, that means the point 2, 2 exists. Okay. Now going back to the blue part, you can see on my screen I graphed y equals x plus 1 and y equals x minus 1. So part A, the part of the function we use the piece x plus 1, y equals x plus 1, is in blue on our graphing calculator. So I'll go ahead and graph it in blue also on our xy axis. And this is where x equals 2, right? That's our second tick mark. So for x less than 2, we're following this piece of the function. So at x equals 0, this piece of the function is defined. So we would have the ordered pair, let's see, 0, 1 would be my y-intercept. If I go up 1 and to the right 1, go to 1, 2. And if I go up another 1 and to the right 1, we get to x equals 2. So the ordered pair 2, 3 would be there, except the function's not defined. That piece of the function isn't defined for x equals 2, so I draw an open circle. Okay, so I'll go ahead and connect these. So notice that that's an open circle at what would be 2, 3. And then going back to the red portion on the graphing calculator, I'll draw that with purple here on my screen. F of x equals x minus 1. So that would go through the y-intercept 0, negative 1, except the function isn't defined for that part of the domain, right? So we would start at 0, negative 1, go up 1 over 1, up 1 over 1, up 1 over 1. When we got over to 2, if x equaled 2, we would have the ordered pair 2, 1, but I'm going to draw an open circle there. Open circle at 2, 1. And then I'm going to continue with the rest of my function. So I'm going to go up 1 and to the right 1. Up 1 to the right 1. And continue drawing my function from there. So we've got these two parallel lines, but they split at x equals 2. F of x equals x plus 1 is in blue on the left side of our function. F of x equals x minus 1 is in purple on the right side of our function. And at x equals 2, the only of those 3 points that's defined is 2, 2. So that's a real point in our function. The other two are open circles. So still this function would pass the vertical line test. If we were to draw a vertical line at x equals 2, it would only intersect that ordered pair 2, 2. It wouldn't intersect either of those two open circle points because those don't actually exist on our function.